Let us look at the next section, students. This section contains 2 paragraphs. Each paragraph has 2 questions each. Each question has 4 options, out of which one or more than one option may be correct. Okay. So if we talk about the comprehension given for question number 37 and 38, students. So we have a tertiary alcohol. It is labeled as X. It is allowed to react with SOCl2, which leads to the formation of P. Now, students, this P is allowed to react with tertiary butoxide to give us the compound Q. So Q must be an alkene, and the Q is then made to undergo reductive ozonolysis to give the compounds R and S. Okay, so R is allowed to react with concentrated KOH to give us CH3OH and T, and then S is separately allowed to react with V to give us this set of products. Okay, so if we look very carefully at the products R and S, students, so we have to backtrace the compound X from R and S. Okay, so if we talk about the reaction from R forming methanol along with the formation of T, students, so we know that R and S are carbonyl compounds. Okay, so R and S are carbonyl compounds, and we can see that R on reaction with KOH gives us CH3OH along with the liberation of T. So students, this is the Cannizzaro reaction which is happening in the presence of concentrated base, students. So if one of the products is methanol, the other products has to be the formate ion. Okay, so there is the carbonyl compound containing only one carbon atom. Okay, so T must be the formate ion, so HCOO negative. It can have the balancing with the K positive. Okay, so this is the compound T which is formed. We can now talk about R, students. So R must be formaldehyde. Okay, so R is HCHO. Okay, if we talk about the reaction of S with V, it leads to the formation of iodoform along with the liberation of this carboxylate anion. Okay, so students, this must be the I2KOH or the iodoform reaction, students. So V has to be I2KOH or its variant. Okay, so if we talk about the compound S now, students, we can clearly see that the compound S has to be butanone or butane 2-one. So compound S is this compound, students. So now we have R and S. So we can figure out the compound which was Q. So R and S are formed from the reductive ozonolysis of Q. So Q must be a combination of these 2 compounds. So Q has to be this structure. So this is Q, students. This on reductive ozonolysis gives us the given carbonyl compounds R and S. Okay. Now, students, this Q is formed from P upon reaction with tertiary butoxide, and we know that P has to be a chloride because the alcohol was substituted using SOCl2. To be more specific, the compound P also has to be a tertiary chloride as the alcohol was tertiary in the first place. So students, the only possibility is that this was the chloride which was taken. So this is P, this was Q, these are R and S. Okay, so students, this must mean that the compound X has to be this compound. Okay, let us look at the questions given to us now. In question number 37, it says the unknown alcohol X which is used in the above conversion is. So students, the IUPAC name of the compound has been given to us. So if we try and figure out its IUPAC name, students, it is going to have 4 carbon atoms in the main chain, and the numbering is going to start from here. So 1, 2, 3 and 4. So it will be a 2-methyl 2-hydroxy compound. Okay, so we have 2-methyl butane 2-ol. And if you look at the options which are given to us, students, we can clearly see that option A has to be marked as the answer for this question. It is 2-methyl butane 2-ol. Okay. Let us look at question number 38 now, students. Identify the statements which is or are correct. Okay. So option A, it says R and S can be distinguished by the tolerance test. So if we look at the structures of R and S, students, R was formaldehyde, S was butane 2-on. Okay, so if we talk about these compounds, they can indeed be separated or distinguished by the tolerance test. The aldehyde will give positive tolerance test, whereas the ketone will not. So option A is correct. If you talk about option B now, the reagent V can be KOI-KOH. So this is also correct, students. So we had figured out that V was I2KOH or its variant. So another variant of I2KOH is KOI-KOH. If you talk about option C now, it says that the molar mass of the salt T is 84 gram per mole. So students, if we talk about the salt T, Salt T was the potassium formate. So we have HCOOK, and if we try and figure out the molar mass, its molar mass is indeed 84 gram per mole. So option C is also correct, students. If you talk about option D now, it says that the compound Q has two geometrical isomers. So if you talk about the compound Q, it was an alkene represented by this structure, and we know that this alkene cannot show geometrical isomerism. Okay, so option D is not correct, students. So for question number 38, we have to mark the correct answer as option A, option B, and option C. Okay. Let us look at the paragraph given for question number 39 and 40, students. The aliphatic aldehyde P and Q react in the presence of aqueous K2CO3 to give a compound R. R upon treatment with KCN forms compound S. S on acidification and heating gives the product which is shown below. Okay. So we have P plus Q reacting in presence of aqueous K2CO3 to form the compound R. Okay. R is allowed to react with KCN. It forms compound S. S on acidification and heating, it leads to the formation of the given compound which was shown. Okay. Now if we try and figure out the compound S, students, we can clearly see that the compound S has to contain a cyanide group. There is a reaction with KCN, so S has to contain a cyanide group. Now students, what must have happened in this case is the cyanide group had converted into the acid group upon hydrolysis, and then the intramolecular acidification must have taken place in this case. Okay. So if we try and backtrace S, students, so this ester must have formed from this acid, students, and this acid has to be generated from the cyanide. So students, this COH would have come in place of the cyanide. So students, compound S must have been this compound. Okay. Now students, R reacts with KCN to give us the given cyanohydrin. So students, there must have been an aldehyde group present over here. So if we talk about R, R has to be this compound. And if we talk about the formation of R from the aldehydes P and Q, students, we can clearly see that it is a beta hydroxy aldehyde. So this means that aqueous K2CO3 must have caused the aldol reaction. In the aldol reaction, students, the reactants can be backtraced by using the beta hydroxy concept. Okay, so we have the beta hydroxy over here. It means that the carbonyl group must be present over here. So we can see that this carbonyl group is HCHO present over here. So if we talk about P and Q, students, one of the compounds is going to be this aldehyde, whereas the other is going to be HCHO. The carbon ion must have generated from the alpha carbon, and then it must have attacked the other carbonyl compound which has no alpha hydrogens. Okay, so one of this is R and one of this is S, students. Okay, so if we talk about the question number 39 now, we have to identify the statements which is or are correct. Okay, so option A, it says nucleophilic substitution takes place between P and Q to form R. This is not correct, students. This is an aldol condensation happening. If you talk about option B now, it says that the molar formula of P and Q is same. This is also not correct, students. P and Q are not the same. If you talk about option C now, nucleophilic addition takes place to form S from R. So we can see that, students, R was the aldehyde, and if you talk about S, S was the cyanohydrin. Okay, so this is a correct statement, students. The nucleophilic addition of Cn minus had happened at the aldehyde to lead to the formation of the cyanohydrin S. Okay, so statement C is correct. If you talk about statement D now, it says that the compound R has two chiral centers. So if you look very carefully, the compound R does not have two chiral centers. It has only one chiral center. Okay, so this is also not correct, students. So out of these given statements, only statement C is correct. So for question number 39, we have to mark the answer as option C. Let us look at the last question for this paper, students. Question number 40. The correct structural formula of the compound S is. So if we go back to the previous slide, students, we can see that the structure S was the cyanohydrin. Okay, so if we look at the options which are given to us, we can clearly see that for this question, we have to mark the Correct answer is option A. So this is it for today, guys. I hope the solutions were clear to you. Thank you.